Hello students, this is a Florida Algebra 1 EOC practice test. As we can see right here, it has 65 multiple choice questions, and what we're going to do is go through all 65 questions to help you guys prepare for the Algebra 1 EOC. On the Algebra 1 EOC, this calculator right here, the TI-30XA, is the only calculator that you're going to be allowed to use. So I have that pulled up so we can actually punch the numbers into the calculator to make sure you guys know how to properly use the calculator. So we're just going to get started now. We're going to start with number 1, and we're going to just go through all 65 questions in order. So for number 1, it says Sandy and Felipe are participating in a walk for life to raise money for charity. Sandy will raise $30 plus $2.50 for each mile she walks. So this is the equation right here for that. Felipe will raise $20 plus $5 for each mile he walks. So we can see that equation right there. If the total amount that each will raise can be calculated using the following expressions, where n stands for the number of miles walked, after how many miles will Sandy and Felipe raise the same amount of money? So whenever you approach this problem, the first thing you need to know is that they need to equal the same amount of money, which means the two equations have to be equal to each other. So we're going to do 30 plus 2.5n equals 20 plus 5n. So all we have to do now is solve for n. So we need to get the n's on one side and the regular numbers on the other side. To do that, I'm going to bring the 20 from the right side to the left by subtracting 20. And then I'm going to bring the n to the other side by subtracting 2.5n from both sides. And whenever we do that, we're going to have 30 minus 20, which is going to be 10, equals, this cancels out because it goes to 0, this cancels out because it goes to 0. This is supposed to be 2.5n. 5n minus 2.5n is 2.5n. So then to get rid of the 2.5 in front of the n, we have to divide both sides by 2.5, divided by 2.5. So to find this, we have to do 10 divided by 2.5. So in our calculator, we're just going to type 10 divided by 2.5 equals, and it should equal 4. So we can see that the proper answer is 4. Sorry, my red lines dropped off there whenever I was typing that in, but we can see that the answer was 4 for number 1. So now we'll go to number 2. For number 2, it says Akeem weighs 140 pounds and hopes to add weight in order to play football in the fall. He hopes to gain between 0.5 and 1 pound per week over the next 10 weeks. Akeem will record his process on the graph below. On the graph, the solid line represents the weight gained of exactly 1 pound per week. That's this line right here. And then the dotted line represents the weight gain of exactly 0.5 pounds per week. So this one was the 0.5, and the solid line was 1 pound. So we'll read the question. It says, if Akeem gains more than 1 pound per week, which region of the graph will contain all the possible points that could represent Akeem's weight gain process? So if this is 0.5 and this is 1, it's going to have to be greater than the 1. So it's going to be in region C. So if we look here, the answer was H, region C, for number 2. That one was pretty straightforward. We'll go to number 3. For this one, it says, Lena sells earrings from a booth at the arts fair. She pays $200 to rent the booth. She makes $5 for each pair of earrings she sells. Her profit P can be found by using the following equation, where N represents the number of pairs of earrings sold. So even though this is a word problem, they actually give you the equation. It would be a little bit harder if you actually had to write the equation, but a lot of times it's a big word problem. They give you the basic equation, and then you have to read very carefully what they're asking for. It says, how many pairs of earrings must Lena sell to earn a profit of $450? And we know that the profit was going to be for variable P. So we're just going to set 450 equals 5n minus 200. And if we just solve for variable n, we're going to get the answer. So to get rid of the 200 from the right side and bring it to the left side, we're going to add 200. And we're going to do that because our goal is to get this variable n all by itself on one hand side of the equation. It doesn't matter if it's the right-hand side or the left-hand side. In this case, it's going to end up being on the right-hand side, but that's fine. So we're going to add 200, add 200. 450 plus 200 is 650 equals 5n. And then we're going to divide both sides by 5. The 5 divided by 5 is going to be 1. So the only thing we're going to have left on this side is n. And then 650 divided by 5, we're going to have to punch into the calculator. So 650 divided by 5. I'm just going to turn it off and then back on. 650 divided by 5 equals 130. So the answer was n equals 130. So the answer was B. Again, I'm not quite sure why the red is clearing whenever I use the calculator, but it doesn't seem like it's a big problem. So 130 was the answer for number 3. Let's go to number 4. Number 4, it says, given the relation shown here, what is the sum of all of the elements in the range? So if we remember, the domain is the possible x values, and the range is the possible y values. So if these are ordered pairs, the ordered pairs are always going to be x comma y. That was weird. X comma y. Just like that. So this is going to be x and y, x and y, x and y, x and y. So what is the sum of all the elements in the range? So what we're going to want to do is add all of these y values up. And to add these up, we're just going to have 5 plus 2 plus 1 plus 3. And if we add all those together, we're going to get 11. So I don't know why they give you all of these different boxes. On the EOC, it should just be one box where you enter your answer, and then you're just going to put 11 as your final answer. And that's all we have to do for number 4. Number 5, it says, what is the value of x in this equation? This one should be real easy. All we have to do is solve for x. So the first thing we're going to want to do is get the x's on one side. I'm going to bring all the x's to this side. So I'm going to subtract 2x from both sides. And then I'm going to bring the 19 over to this side by subtracting 19 from both sides. So minus 2x, or minus 3x minus 2x is minus 5x. And then we have 106 minus 19. And I'm not going to use the calculator over there because it seems like it's going to clear the red. So let me just look at my sheet here. It looks like that's going to equal 87. So to finalize, we have to divide both sides by negative 5. And we get x equals negative 17.4. So for the answer, we're just going to put negative 17.4 in the answer box. Number 6, or number 5, that was pretty straightforward. This is the answer to this one, sorry. So this should have been negative 17.4 here. We didn't want to put it in the answer box for number 6. All right, so we're done with the first 5 problems. Let's do number 6. Just for the sake of room on the page, I'm going to actually solve this one right here. So we have the square root of 243 minus the square root of 75 equals the square root of n. What is the value of n? So they don't want us to actually factor anything out necessarily. They want us to have all of the terms underneath the expression here. So let's look at how I solve that one. All right, it doesn't look like I actually have it solved, so we'll just have to solve it right now. So if we type in the square root of 243, I don't think that's going to be a perfect square, but we can try it. The square root button, we can use the square root button here because it's just a second root. If it was a third root, we would have to use this one right here. But for this, on this calculator, we actually just type in 243. And then we're going to hit this button right here for the square root. And yeah, it equals 15.5. So that's not a perfect square. So what we're going to want to do is we're going to want to start finding the prime factors of 243. So we're going to do a factor tree of 243, and then we'll do a factor tree of 75. For 243, we're going to do, this is going to be divisible. It's not divisible by 2 because it's not even. So we're going to go to the next prime number. The prime numbers are going to be 2, 3, 5, 6 isn't prime, 7 is prime, 8 isn't prime, 9 isn't prime, 10 isn't prime, 11 is prime. So whenever we're doing these prime factor trees, we just start out with the first prime number and see if it's divisible by it. If not, we move on to the next one. And if it's not factorable by the time you get to 11, it's probably a prime number itself. So in this case, we're going to do 3. So we have 3. And 243 divided by 3, I actually don't know what that is. Let me see if I can use the calculator without it clearing. 243 divided by 3 equals, it equals 81. And then 81 is going to be 9 times 9, and both of these are going to be 3 and 3, and 3 and 3. 75, it's not divisible by 2. It is divisible by 3, but I think it's actually going to be easier to divide by 5. So we have 5, and then 75 divided by 5. Let's do that. 75 divided by 5, just to make sure we have it right. Oops, I hit a button wrong. 75 divided by 5. I guess I'm not hitting the divide. Let's try that one more time. 75 divided by 5 equals 15. And then from 15, we're going to have 3 and 5. So now we can draw these as the square roots. So the square root of 243 is going to be the square root of 3 times 3. There's going to be 5 of them. 1, 2, 3, 4, 5. Times 3 times 3 times 3. For the square root of 75, it's going to be the square root of 3 times 5 times 5. So now that we have these, I'm actually just going to erase the prime factor tree so we have more room. I guess I can write what this one was. This was 75. So it's going to be minus this. This one was 243. So whenever we're actually pulling numbers out of a square root, we're going to do it in pairs of 2. So that's going to be a 3 outside. We're going to do another pair of 3s, which is 3. So we have 3 times 3 here. And here we can pull out a set of 5s. So we're going to have a 5 pulled out. And then we're basically going to be crossing these inside ones out. 3 times 3 is 9. So we have 9 times the square root of 3 minus 5 times the square root of 3. And whenever you're subtracting radicals, you subtract the numbers out front and you leave the radical the same. So we just have to do 9 minus 5, which is 4 times the square root of 3. So this actually is the correct answer. But if you look at the form that they wanted in here, they want it to just be the square root of n. This is actually how you would write the simplified radical. But since they're asking for it just as the square root of n, they don't want any numbers out in front here. So we actually have to try and bring this number 4 back in. And in order to do that, this would actually be equal to the square root of 4 times 3. So 4 times 4 is 16. 16 times 3, just to make sure I get it right, I'm going to punch it in the calculator. 16 times 3 equals, it equals 48. So this is going to be the square root of 48. So in our answer box, we don't actually type in the square root of 48 because it says, what is the value of n? N is actually the number underneath the radical. So in our answer box, all we're going to type in is 48. And that should be the answer to number 6. And we're going to move on to number 7. So I'll clear my calculator and I'll clear this problem, and we're going on to number 7. All right, so for number 7, it says, what is the solution of the system of equations below? So here we have 2 equations. This is equation 1 and this is equation 2, and we have 2 unknowns. We don't know what x is and we don't know what y is. If you have 2 equations and 2 unknowns, you can solve it with substitution. So we have y equals 4x minus 10 and we have y equals 2x. So to solve this, we all want to have one equation that has all of the variables, all of the same variables. So what we do is if we actually plug this 2x in for y up here and we rewrite it, we'll have 2x equals 4x minus 10. And if you see, now we have one equation and we only have one unknown, which is one variable, which is x. So if we solve this, we're going to get the value for x, which will be the first number in our ordered pair. So we have to get rid of the 4x from this side by subtracting 4x. Since we subtracted 4x from the right, we also have to subtract 4x from this side to make sure the equation stays equal. So we have 2x minus 4x, which is negative 2x, equals 4x minus 4x. That goes to 0, so we just have minus 10 on this side. And then we divide both sides by negative 2, and we get x equals 5. So we know the answer is already A, just by getting the first value of x. But to get the value of y, we can actually plug the x value in to either of the equations. The easier equation to plug it back into is going to be just y equals 2x. So y equals 2 times 5, so y equals 10. So that confirms that we have both of the values in the ordered pair, 5, 10. This is the x and this is the y. And that concludes number 7. We will now move on to number 8. Number 8 says, in our catering business, Mariah prepares and serves Italian food. The amount of lasagna is prepared according to the following table. So we have the number of guests. This is going to be the x value, and the pans of lasagna, that's going to be the y value. It says, based on the pattern of the table, how many pans of lasagna should be prepared for 250 guests? So let me just go to the problem real quick to make sure I approach it right. So what we can do is we can write this as a linear equation where we have y equals mx plus b. In this case, the b is going to be 0 because if you have 0 guests, you need 0 pans of lasagna. So we're going to have to figure out what the slope is. So in the x, we're actually incrementing by 10, and in the y, we're incrementing by 3. And that pattern holds true for all of them, as this one increases by 10, this one increases by plus 3. I guess we can write plus 10 and plus 3. So for the slope m, this equals the change in y divided by the change in x. So if we look at the change in y, that's going to be the pans of lasagna, which is increasing by 3, and then the change in x is increasing by 10. So our slope is 3 over 10. So y equals 3 over 10x. Now, if we have 250 guests, guests are going to be our x value. So all we have to do is plug 250 in for x right here, and we'll get our answer. So y equals 3 divided by 10 times 250. So if we're going to use our calculator over here, hopefully it doesn't erase. But we're going to turn it on, and we're going to do 3 divided by 10 times 250, and we're going to hit equals. So it equals 75. It did clear, and I'm not exactly sure why, but we do know that the answer is going to be 75. Let me just double check that that is the right answer. Yeah, it was going to be y equals 75. So in your box, it just says, based on the pattern, how many pans of lasagna should be prepared? The answer was 75. And that's number 8. Looks like we're 20 minutes in on problem 8. So we got to keep cruising here. Number 9. This one says, Mrs. Sanchez writes the following table of x and y values on the chalkboard and asks the class to find the equation that fits the values in the table. Which of the following equations describe the relationship between x and y? So this problem is actually pretty straightforward. The first thing we're going to have to do is calculate the slope. And you guys should have memorized that the slope equals y2 minus y1 over x2 minus x1. We know that this is basically, you can call this x1 and x2. This would be y1 and y2. And you could plug these values into this equation to calculate the slope. That would be the long way to do it. What I usually do is I just know that m equals your change in y divided by your change in x. So I just look, what is my change in x? From -2 to 0, that's going to be +2. From -6 to -2, that's going to be +4. So my change in y was 4, and my change in x was 2. 4 divided by 2 is 2. So I know my slope is going to be 2, so I have y equals 2x, and then I have to figure out what my y-intercept is. So in standard form, this would be y equals mx plus b, where b is my y-intercept. I know my y-intercept is the value whenever x equals 0. So in this case, my y-intercept is -2. So I know the equation is letter A. Now, this was actually easy because they gave us the value where x equals 0 in the table, but according to Florida standards during the EOC, it's very unlikely that they're actually going to give us this value here. So if they didn't give us that value and we had to calculate for the y-intercept to finish the equation, also just by knowing the slope, if it was actually multiple choice, we would be good to go because that was the only one that had the slope of +2. But they might actually have you write out the full expression. So if we weren't doing it this way, and we know the slope, and we know a point, you would actually want to put it in point-slope form. You would want to call this first point x1, and this point here y1. And you'd want to put it in point-slope form. Point-slope form is y minus y1 equals m times x minus x1. Like that. And whenever we plug in these values, this value of 2 is going to get plugged in here. This value of -6 is going to be plugged in here. And our slope value is going to be plugged in for m. Whenever you plug things into point-slope form, never, ever plug in a value for x and y. X and y always just stay x and y in point-slope form. So we're going to have y minus y1, which is a -6, equals our slope of 2. X stays x, minus x1. x1 is a -2. So in this case, I turn my double negatives into big plus signs. And then from there, the first thing we have to do is, I'm going to try and convert this to slope-intercept form because that's the form of all of our answers. So the first thing we do is just to distribute. So we have y plus 6 equals 2x plus 4. And then we're going to have to get rid of this plus 6 by doing -6. 4 minus 6 is going to be the -2. So we're going to have y equals 2x minus 2. And as you can see, we were able to get the same answer without knowing the y-intercept from the table right there. So it's good to know how to do it both ways. And that includes number 9. We're going to go on to number 10. Here we go. It says, Lamar works in quality control section of a toy company. The factory is producing 3,000 Steelman action figures. Lamar randomly chooses 120 of them and examines them for defects. Of these 120 figures, 8 of them had defects. If this ratio holds true for all 3,000 figures, how many additional figures of the remaining 2,880 would have a defect? So we're going to write this as a, let me just make sure that I look at the problem real quick. Yeah, so we're just going to write this as a simple ratio where we have 8 defects divided by 120. This is going to equal some number of defects divided by the total number, which is 3,000. 3,000. So if we solve for x, this will give us the total number of defects. So if we have x divided by 3,000, and we're trying to get x all by itself, we're always going to do the opposite operation. So this is x. This line here means divide. X divided by 3,000. So the opposite of dividing by 3,000 is multiplying by 3,000. Because 3,000 divided by 3,000 is 1. 1 times x is just x. So on this side, we're going to have x. But since we multiplied this side by 3,000, we also have to multiply this side by 3,000. So I'll try and use my calculator over here. We're going to do 8 divided by, oh, it cleared it. Let me rewrite it real quick what we had. We had 8 divided by 120 equals x divided by 3,000. And then we were multiplying both sides by 3,000. We have to multiply this side by 3,000. So if we do 8 divided by 120, and then we multiply that by 3,000, we end up getting x equals 200, right? And the first time I did this, that's actually what I thought the answer was. But it's actually really important. You should actually spend like 80% of your time just reading the problem carefully and making sure you understand, you know, what it's asking, so you don't miss an easy question. It says how many of the additional figures of the remaining 20 of 2,880 would have a defect. So we have to take into account that the first 120 had 8 defects. So our final answer for the total equals 200. We have to subtract the 8 that were in the first round of defects, because we only want the additional defects, not the total number of defects for the 3,000 figures. So you have to read what it's asking for. 200 minus 8 is going to be 192. So the proper answer is G. So that one was a little bit tricky at the end. And we're going to go to number 11. This is a really good problem. I'm actually going to go all the way up to the top to solve this one because I'm going to need a lot of space. And we're going to solve this one 2 different ways. But we'll read the problem real quick. It says the height h of an object after t seconds is given by this equation. So h equals negative 2t squared minus 9t plus 56. And how many seconds will the object hit the ground? So the first thing we have to think about whenever we see this problem is, what is the height of the ground? Because that's what h is when the object hits the ground. So the height of the ground is 0. So the actual equation we're going to use is negative 2t squared minus 9t plus 56 equals 0. So if we look at that equation, we know that that's a quadratic equation. So there's going to be 2 different ways we can solve this. We can actually solve this using the AC method because our a value is greater than 1, or just like any quadratic function you have, you can solve it with the quadratic formula. So just because I don't really have any room to solve this here, I'm going to rewrite that at the very top of this sheet where it's nice and blank. So I'm going to solve it right here. Hopefully. Here we go. So again, the equation that we had was h equals negative 2t squared minus 9t plus 56 equals 0. So the first method I'm going to use is going to be the AC method. Whenever you're factoring a quadratic equation, the first thing you have to determine is, can I factor out a greatest common factor? In this case, none of the other terms are going to be divisible by 2, so I can't actually factor out a GCF, but you're actually not supposed to have a leading term as a negative, so I am going to factor out a negative 1. So I'm going to do negative 1, and when I factor out a negative 1, I'm going to make the opposite sign for all of the terms. So this is going to be 2t squared plus 9t minus 56, like that. This term, you're going to actually end up setting this equal to 0, so negative 1 equals 0, and that's not actually going to find you a root. So you're not really going to have to worry about that whenever you're actually finding the final values. So what we really have to do right now is just solve this problem and see which one of our roots is positive, and that one is going to be our answer. So for the AC method, we're going to draw a box over here. We have to find something that multiplies to a times c and adds to b. And if you remember, this is in standard form, so ax squared plus bx plus c equals 0. So our a equals 2, our b equals 9, and our c equals negative 56. So 2 times negative 56, let me see if I have this drawn out. Yeah, 2 times negative 56 is negative 112, and we're going to add to b, which is 9. So what we want to do is we want to list all of our factors that will add to 9 and multiply to negative 112. So if you want to, you can list all your factors, but I actually know that it's going to be -7 and 16. And for the AC method, what we're going to want to do, so I'm just going to erase this, we're actually splitting our b term up into those two factors. So we have 2t squared. The 9t is going to be -7t plus 16t minus 56 equals 0. And now we're going to solve this by grouping, like this. So what can we pull out? What is the GCF of this first group? We can't pull out any number because 2 and 7 are both prime, but we have to pull out the variable with the smallest exponent, which in this case is t to the 1. So we're going to pull out a t, and whenever we do that, if we divide both terms by the t to get these two new terms here, we're going to have t squared divided by t, which is just going to be t. So it's 2 times t minus 7, because t divided by t, 1 minus 1 is 0, t to the 0 is 1, -7 times 1 is -7. And then we're going to do plus. We have to figure out what is the greatest common factor here, and we know that this term is going to be 2, so 16 divided by 2 is 8, so we're going to want to pull out an 8, and that's going to be 2t minus 7. And now we're almost have our two factors. So one of the factors is going to be this binomial here that's repeated, and the other one is going to be the numbers outside of the two binomials, which is t plus 8. So we have t plus 8 as the one factor, and then we have 2t minus 7 as the second factor. Now if it asked for what the factor was, it would be one of these two factors. But in this case, it wants us to actually solve the problem, because it's actually asking for how many seconds will it be when it hits the ground. So it wants to know what t is. So we have to set both of the factors equal to 0 to actually find the roots or to find the solution of the problem. So we have t plus 8 equals 0. Whenever we solve for t, we're going to subtract 8 from both sides. So t equals -8. We don't actually want the value to equal negative, because if the object strikes the ground in negative seconds, that doesn't really make sense. It means it would strike the ground before it even lifted off. So hopefully the other one becomes positive. We have 2t minus 7 equals 0. We're going to add 7 to both sides. So now we have 2t equals 7. To get rid of the 2, we divide by 2. We have 7 divided by 2, so t equals 3.5. And that's going to be seconds. And that is the answer to the problem. Now, we know the answer is t equals 3.5 seconds, but let's look at how it asks us to enter the thing. It just says, in how many seconds will the object strike the ground? Normally, they will say, enter your answer into the box. Do not include units and do not include variables. So if that were the case, it would only be 3.5. So if we scroll down, we're just going to enter 3.5 into the box for number 11. So this is just going to be 3.5. And then we're done. If they ask for units, you could put seconds, but most of the time they're not going to want the units and they're not going to want the variable, just so it's easier whenever you enter it in. And that is number 11. On to number 12. Let me look at the problem real quick. All right, so it says a scale model of a rectangular plot of land is 13 inches long by 12 inches wide. If the actual length of the plot is 780 feet, what is the actual area in square feet? So we know we're going to eventually use the area equation, which equals length times width. But first we have to determine what the length and width are. So we actually know the actual length, we're good, but we need to determine what the width is. And we know the length of the other model. So it says 13 inches long. So we're looking for, the actual model is 780 feet. The model is 13. We want to know how wide it is. I'll actually use the variable w for width divided by 12. So if we solve this, we will get the width of the model. So to do this, we actually have to multiply both sides by 12 because we're trying to get w by itself. 12 times 12, this goes to 1. 1 times w is just w. So our width In our calculator, I would type 780 divided by 13 and then multiplied by 12. And it looks like our width is 720. I would enter it into the calculator, but I don't want it to clear all of the writing. So now we know that the length is 780 and the width is 720. So all we have to do is area equals 780 times 720. And if you multiply 780 times 720, I'll try it real quick, but just note that it might get erased. So we're going to do 700, we'll turn this on, 780 times 720 equals, and it's 561,600. So the answer to number 12 is I. And we're done. All right, number 13. Number 13, we didn't talk too much about this in class. It's about containing elements, but let's read this and see if we can figure it out. So it says set A contains 20 elements, set B contains 15 elements, and set AB, this means in set A and B contains 6 elements. So 6 elements are in A and B, so they're in both A and B. So how many elements are contained in the set AB? So yeah, this is actually the number in common with both. So in this case, the first one has 20, and the second set had 15, and the set contains 6 elements. So 6 of the elements are in common with both. So we actually have to do minus 6, and 20 plus 15 minus 6 equals 29. I'm not sure if I explained that the best, but that is the proper answer. It says how many elements are contained in the set AB? Yeah, that's the answer. I actually don't understand that one 100%. It's kind of a weird question that I don't really expect you to see something like that, so I wouldn't worry about it too much. We're going to move on to number 14. This one, on the other hand, is a really good question. It says, in factoring the expression, which of the following is the greatest common factor? So in this case, it's multiple choice, so we can actually just check which one of these numbers is the greatest common factor. If you wanted to actually solve it outright, I can show you how to do that. We'll just do 2 prime factor trees. So in this case, we're going to do 12 and 20. 12 is going to be 2 and 6, and it's going to be 2 and 3, and then 20 is going to be 2 and 10, and 2 and 5. So we look for the prime numbers that are in common with both. So this one has 2 2s, and this one has 2 2s. So the greatest common factor is actually going to equal 2 times 2, which equals 4. So for the number portion, we know the greatest common factor is 4. Since it was multiple choice, you could have just divided 12 by 4, that works. You can divide 20 by 4, that works. If I tried to divide 12 divided by 8, that's going to give me 1.5. That's not good because it's a decimal. It has to be a whole number. Otherwise, it's not considered a perfect factor, so you don't want to use it. So we know that the GCF is going to equal 4. And then for the variables, we have to pick the variables that are in common with both of them, or in common with all of the terms. In this case, there's only 2 terms, and it has the lowest exponent. So in this case, they both have an x here, and the x that has the lowest exponent is x to the 2. So the greatest common factor is going to be x2. And for the y, they both have a y. The lowest y is y to the 1. So we're just going to write y. So the answer is H. If we were going to actually factor this, because sometimes they will ask you to factor it, what we want to do is once we have the greatest common factor, we want to divide both terms by the greatest common factor. So 4x squared y and then 4x squared y. Sorry if it's a little small. So not equals. So the two terms are going to be, this is going to be one term, and then this is going to be the second term. So plus here. So the first term, 12 divided by 4 is going to be 3. X squared divided by x squared is 1, so we don't have to write that. Y3 divided by y is y2. And then x3 divided by x2 is going to be, well, first 20 divided by 4 is 5. And then x3 divided by x2 is x. Y divided by y is 1. So this would be our final answer for the factored expression. It would be 4x squared y times 3y squared plus 5x. They didn't ask us to do that, but it's very likely that they could ask you to do that. So this is the greatest common factor, and then this is the factored expression. All right, number 15, moving right along. It says, given the equation a equals b plus c squared d, which of the following is the correct expression? This is a super easy problem, but people for some reason always mess up because it's just basic algebra. So first we have to look for what do they want. It says the correct expression for d. So they want us to solve for d, which means we want to get d all by itself. So we have a equals b plus c squared d. So if we're trying to get d by itself, we have to get rid of the c squared and we have to get rid of the b. The first thing we want to do is not the term we have to divide. We always want to get rid of the term that we're adding or subtracting. So to get rid of b, we're going to have to do a minus b. So minus b, so we have a minus b equals c squared times d. Now to get d by itself, this is c squared times d multiplied by d. So the opposite operation of multiply is divide. So we have to divide this term by c squared. We have to divide this term by c squared. C squared divided by c squared is 1. 1 times d is just d. So we have a minus b divided by c squared. So if we look at our possible answers, we can see that the answer is C. Now some people get a little bit confused because sometimes there'll be like a square root in one of the possible answers and they'll pick that. In this case, none of them are going to be needed to be square root. But just so you know, if we had something like c squared equals 4 and we were solving for c, to get rid of an exponent, you would actually do the square root of both sides. Well, the square root of this side, because the square root of c squared is c, and then the square root of 4 would be 2, because 2 times 2 equals 4. So if they made you do something with, if they actually wanted you to solve for the term that did have an exponent, you would have to take the root or the radical of that exponent to get rid of the exponent. But they didn't ask for it, just extra information. So we're done with 15. Let's go on to number 16. It says, what are the coordinates of the x-intercept of a line that is represented by this equation? So what are the coordinates? So that just means what is the ordered pair? So they're looking for, this is the x, this is the y, of the x-intercept. Anytime you're solving for the x-intercept graphically, this is the x, this is the y. So whenever you're solving for where it intercepts the x, your y value is going to equal 0. So to solve this, we actually want to plug in 0 for the y. So we have 7x plus 4 times 0 equals 28. 4 times 0 is 0. So we have 7x equals 28. We're going to divide by 7. X equals 28 divided by 7 is 4. So again, in our ordered pair x comma y, we know that our y was 0 and our x is going to be 4. So we want the one that is 4 comma 0. And that is correct. Some people might get confused and end up picking F, but H is the proper answer. All right, that one was pretty easy. Let's go on to the next one. And one more thing on this one, I guess. This actually isn't in standard form. It was actually easier to not put it in standard form because we were going to have to bring the 28 right back to that side. But it is important to note that a lot of times it actually is good to start in standard form. So if this was in standard form, it would be 7. Let me just think for 1 second. Oh, actually that is standard form for a linear equation. Sorry, I was thinking quadratic equations where you want it to equal 0. Standard form of a linear equation is ax squared plus bx. Oh wait, not ax squared. What am I saying? It's ax plus by equals c. So in this case, this was standard form. Sorry, for some reason I was thinking that the 28 needed to be on the other side to solve it, but that's not the case. That's only the case for quadratic equations. It's really important for quadratics, but it's not important for linear equations. That is standard form. All right, sorry for that. Number 17, here we go. So for this one, it says, for the simplified form of the product here, what is the sum of the coefficients of the x squared term and the x term? So the simplified form of the products means that they want us to use FOIL to multiply that out and then determine what the sum of the coefficients are. The coefficients are going to be the number in front of the variables. So like this coefficient would be 3. The 7 actually does count as a coefficient, but in this case, it's not going to be the x squared or x term, so we're not going to have to worry about it. But let's FOIL this out and then write our answer. I'm going to make this a little bit bigger. I think maybe I've been having stuff be a little bit too small. All right. So let's multiply this out using FOIL. So we have 3x squared times 2x, which is 6x to the third, because 3 times 2 is 6, x squared times x. You're going to add the exponent, so it's 2 plus 1, which is 3. Now we have to do, that's the first terms, the outer terms. 3 times 9 is going to be plus 27x squared. That's the first two terms. Now we're going to do 7 times 2x, which is going to be plus 14x. And then we're going to do 7 times 9, which is plus 63. Now it asked us for what is the sum of the x squared term and the x term. So 27 plus 14. 27 plus 14 equals 41. So in our box, we would put 41 as the answer. And that's all there is to that one. Let's go on to the next one. Number 18, it says, which of the following is a sufficient condition to show that a graph of equation does not represent a function? So for this, they're asking about whether something is a function or is not a function. To determine whether something's a function, the easiest way to do it is the vertical line test. So if you have your coordinate plane, x and y, if you have a function like this and you draw a vertical line and all of these vertical lines only cross one point, then that's a function. If I have another function, I'll erase this one. If I had something like this, where I had a U shaped the other way, and I draw a vertical line, it crosses two different points whenever you draw that vertical line. That's called the vertical line test. That is not a function. So if we look here, it says a vertical line intersects the graph at more than one point. So we know that this is not a function. So the answer for number 18 is I. All right, we're moving on. This one, it says, what is the result of multiplying these two numbers? So we actually know that the first number is going to be 48 because 6 times 8 is 48. And then we're going to do the next terms, which is x squared times x squared, because it says you're multiplying. So whenever you're multiplying two variables, you add the exponents. So it's going to be 2 plus 2, which is going to be x to the fourth. This is y to the 1. 1 plus 4 is going to be y to the 5. And then 3 plus 3 is going to be z to the 6th. So that one was super easy, except, oh wait, 48. I didn't write the 8. So we know it's 48. It doesn't actually show any of these as the correct answer. But this one shows 48x to the 3, y to the 5, z to the 4th. This should be a 4th. That's a typo. They didn't give you the possible answer, but the answer would be D. Well, it wouldn't be D. That's the actual answer. I don't know why they were wrong, but they were. Number 20. Let me look at it real quick. All right. So for this one, it says at a planetarium show, children's tickets cost $10 a piece and adult tickets cost $20 a piece. There are only 2 types of tickets sold. At the recent show, these are the only 2 types of tickets sold. At a recent show, 29 tickets were sold for a total revenue of $430. How many children tickets were sold? So we'll start out by writing that the children's tickets were $10. So I'm going to do 10. I'm going to use the variable C to represent children's tickets. We could even put a $sign here. And then we're going to add the adult tickets were $20. So $20 times A for adult equals the total revenue of the tickets, which was $430. So from there, we want to solve for the children's tickets, but we can't just solve for C because we have this variable A here. So we have one equation with 2 unknowns, so we're going to need to write a second equation. We know that the number of adult tickets plus the number of children's tickets equals 29. So we actually want to solve for C. So we're going to get C on one side of the equation. We're going to solve for A, and we're going to plug in the expression that we're going to solve for A for, once we solve for A. So A equals, to get rid of C, we do minus C. So we're going to have 29 minus C. That's what A is, right? So we can actually plug this 29 minus C in for A, and then we'll have an expression that only has one variable. So we have 10C plus 20. Instead of writing A, I'm going to write 29 minus C equals 430. Now we have one equation and one unknown. So if we solve this, we'll get the answer for the number of children tickets. So first we have to distribute by doing 20 times 29. 20 times 29 is going to be 580. So we have 10C plus 580 minus 20C equals 430. So now we can combine like terms. So we have 10C minus 20C, that's going to be minus 10C. But we also want to get rid of this 580, so we're going to do minus 580 from both sides, minus 580. 430 minus 580 is, I think it's negative 150. That looks right. And then we're going to divide both sides by negative 10. So negative 10 divided by negative 10 is a positive 1. So we're left with C equals negative 150 divided by negative 10 is positive 15. So the answer was C equals 15, and that was answer G. All right, here we go. Going on to number 21. All right, so it says, what is the solution for x in this inequality? So remember, an inequality, this is the inequality symbol. Actually, I'll make this a little bit bigger before we start so that you can see it better. All right, so guys, this is the inequality symbol. You would read this, negative 3x plus 4 is less than 16. So we solve this for the variable x, and we do that by treating it just like this was an equal sign. The only thing different we do for an inequality versus an equality is if we multiply or divide both sides by a negative number, we're going to flip the inequality. So if this was less than, we would flip it to be greater than. Other than that, you solve this exactly like it was an equal sign. So to solve for x, the first thing we're going to do is subtract 4 from both sides. So we have negative 3x is less than 16 minus 4 is 12. We're going to divide both sides by a negative 3. When we divide both sides by a negative 3, this is when we're going to flip the inequality. Negative 3 divided by negative 3 is 1. 1 times x is just x. 12 divided by negative 3 is negative 4. So you would read this as x is greater than negative 4, which is answer B. That one was really easy. All right, let's look at the next one. It says, I'm going to try and make it as big as possible. All right. It says, what are the coordinates of the y-intercept of a line that is represented by this equation? So it's looking for y-intercept. It's looking for the y-intercept. You want to solve it for when x equals 0. When x equals 0, remember from this is x, this is y. When x equals 0, you're going to find some value of y. So all we have to do is plug a 0 in for x and solve for y. And then our final ordered pair, the x is going to be 0. So by default, we actually already know the answer is going to be one of these two. So we're going to have negative 5y equals 30, because 6 times 0 just makes that term go away. So negative 5 equals 30, negative 5y equals 30. Divide both terms by negative 5, and we get y equals 30 divided by negative 5 is going to be negative 6. So we know that our correct answer is answer F. All right, again, that one wasn't too bad. Now we're moving on to number 23. Let me make sure this is still recording yet. We're 56 minutes in, and we're on question 23, which isn't too bad. We almost have half the test done, and we're only 1 hour in. So we're making pretty good time. What is the value of x in this equation? So all we have to do is solve this equation for x. That should be pretty easy. I'm going to make this a little bit bigger again so we can see. So those are the possible answers. So whenever we see this, the first step we're going to want to do is we're going to want to distribute. So we're going to want to do, oops, I have to make a little line on the board so it doesn't do that. That's why I always start with this. We'll just solve it and we'll see what the answer is. So we do 5 times 2x and then 5 times negative 3. And we do 2 times 7x and then 2 times 2. So 5 times 2x is going to be 10x. 5 times negative 3 is minus 15. 2 times 7x is plus 14x. 2 times 2 is plus 4. And that's going to equal 37. Now all we have to do is combine like terms. 10x plus 14x is going to be 24x. To get rid of these terms, well, I guess I'll do negative 15 plus 4. That's going to be minus 11 equals 37. To get rid of the minus 11, it's going to be plus 11 plus 11. So we have 24x equals 48. We're going to divide both sides by 24. We're going to get x equals 2. So that's the answer. Let's just make sure that that was one of the possible answers. Yeah, the answer was A, number 2. On multiple choice questions, sometimes it's better not to look at the possible answers because they might try and trick you with a close one that just looks like it's right. So it's good to solve it and then see if you got one of the possible answers and pick that one after you read carefully that that's what they were asking for. All right. Again, this looks like a big word problem, but I'm guessing it's going to be pretty straightforward for number 24. It says a health club charges $150 per month for each member, plus an hourly rate of $5 for the use of club facilities. The function shown below can be used to determine the cost in dollars per month for the use of the health club facilities. So f of h equals 150 plus 5h. It says Janine used the club's facilities in October, November, and December. If she paid $300 in October and $380 in November and $330 in December, how many total hours did she spend in the club during these 3 months? Okay, so this is not quite as easy as I thought. So this is the base equation, but it looks like there's actually going to be 3 months involved. So f of h is going to be the total price for all 3 months. So we actually have to do 300 plus 380 plus 330. If we add all of those together, we get a value of 1010. So we have to set 1010, I'm just going to do it here, 1010 equal to the 150. That was the charge per month, but since we have 3 months, we have to multiply that times 3. So 150 times 3 is going to be 450, and then plus 5h stays the same, so plus 5h. So if we solve that equation for h, we'll actually get the number of hours she spent for the total of the 3 months. So we have to subtract 450 from both sides, minus 450. So 1010 minus 450, that should be 560 equals 5h divided by 5 divided by 5. 560 divided by 5 should be our answer. I'll try and use the calculator. 560 divided by 5 equals 112. So she spent 112 hours. You wouldn't want to write hours, but that is the answer. It's 112. All right. So on the EOC, there's going to be about 50 questions. We're on question 25. We're halfway done, and it's been 1 hour and 1 minute since we started. So for this one, what is the slope of a line that contains these points? If you guys can't do this, you're in trouble. But the equation for slope is not given to you on your formula sheet. But of course, we know that m equals the rise divided by the run, which we can call change in y divided by change in x. But most importantly, you should have this memorized: y2 minus y1 over x2 minus x1. This is the equation that we're going to want to use here, because we have 2 points. This is x1, y1, and then this one is x2, x2, y2. So we're going to do y2 minus y1 to start. So that's going to be 4. You see there's a minus sign in the equation, and there's a minus sign in the -7, so it's 4 minus a -7 divided by x2, which is -6 minus a -2. So we're going to turn these double negatives into big plus signs, and we have 4 plus 7 is 11. -6 plus 2 is going to be -4. So 11 divided by -4 is our slope. I usually leave it as a fraction like this, but if you divide out the fraction and it's a non-terminating decimal, or it's a terminating decimal, which means it doesn't go on forever, that is actually an exact solution too, which in this case, if you do 11 divided by -4, you would get -2.75. So that is an exact answer. So both of these should be valid answers on the EOC, but if this number is like -2.75343, and it just keeps going forever, that would not be an exact solution, and you would definitely want to write it as a fraction, because that's the only one that has the exact right answer. And that is number 25. Moving on to number 26. All right, number 26, it says a line is shown on the coordinate grid below. So if we look at this, we just want to figure out what the equation is in slope-intercept form. Slope-intercept form is y equals mx plus b. Let me move this out of the way. So the first thing we want to do, well, we can just find the y-intercept really quick. It's right there. So we know it's going to be +3, and we just have to determine the slope. To determine the slope, we want to find points on the grid where it crosses exactly. In this case, it actually crosses a lot of points exactly, but for the sake of it, I'm going to pick this point and this point here. And I could actually list these points. The x is -3, the y is 0, And then for this one, the x value is 0 and the y is 3. And I could use my slope formula, y2 minus y1 over x2 minus x1. But that would be a lot of work. And the quicker way to do it would just be, first we know that the slope of this line, think about whether it's positive or negative. Because as we go from left to right, this is increasing, so the slope is going to be positive. That's how you determine the slope. If you go from the left to the, if you go from the right to the left, you would say, oh, it's going down, it's negative. You always try and look at a line if it's positive by going from the left to the right, going this way. And since it's going up, it's positive. That's just a side note. So we know the slope is positive, and then we know that the m equals the rise over the run, which is the change in y over the change in x. So first we'll do the rise. 1, 2, 3. So the rise equals 3, the run. So the run, we're going to start at the point here, and we're going to go over 1, 2, 3. So the slope is 3 over 3, which equals 1. So y equals, if you have 1, you just need to write x. So y equals x plus 3 is the answer, which is answer H. That one should have been real easy. I was just explaining a little bit more in detail. Number 27. So for this one, it says we want it to be expressed as the square root of x. What is the value of x? And if you remember from the boot camp review, anytime we are multiplying or dividing radicals, you multiply and divide the numbers in front, and then you multiply and divide the numbers underneath the radical. So in this case, we're going to do 6 times 3, which is 18, divided by 2. So we're going to have 9, and then we have to do the radicals. 5 times 6 is 30. 30 divided by 10 is 3. So we're going to have 9 times the square root of 3 as the answer for number 27. So that is actually the correct simplified radical expression. But it didn't ask us for the most simplified radical expression. It asked us to express it like this, where we have the square root and then we have a value of x. So we want all of the terms to actually be underneath the radical. So if we're bringing the number from outside of the radical into the radical, we're actually multiplying it by itself twice. So that would actually be the square root of 9 times 9 times 3. 9 times 9 is 81. 81 times 3 is 243. So we would have the square root of 243. Now again, it only asked us for the value of x. The value of x in this case is 243. So we would write 243. Again, you shouldn't have these multiple boxes. You're probably just going to have one box where you would write 243. And that's the answer to 27. All right. So for this one, it says a function is defined with the following. This is a quadratic function, and this is called functional notation. This f of x is the same as y equals this, but you actually know what the y is for a specific value of x. So it says if the domain is these possible values, what is the highest range value? So the range is the possible y values. So what we actually have to do is we have to plug all of these different x values into x and then solve for y. And whichever y value is the highest will be the answer. So let's just get to it. So f of 0, so if we plug a 0 in for x, we're going to have negative 0 squared plus 11 times 0 minus 5. Now, 0 squared is 0, negative 0 is still 0, 11 times 0 is 0, so this goes to 0, this goes to 0, and we're just left with negative 5. 0 plus 0 minus 5 is negative 5. So this equals negative 5. So we've already done the first one, now we're going to do f of 6. Now in this case, when we plug the 6 in, we're just going to put it in parentheses. So this negative is actually outside of the parentheses, not inside the parentheses. So we're going to have negative 6 squared plus 11 times 6 minus 5. Now, 6 squared is 36, but we're going to have minus 36 plus 66 minus 5. And if you do that, the answer of f of 6 is going to be 25. I'll start a little further back for the next one. Let's do f of 8. So we're going to solve for y. When x equals 8, we're going to have negative 8 squared plus 11 times 8 minus 5. 8 squared is 64, so we're going to have negative 64. And then plus 88 minus 5. And for f of 8, that's going to add up to 19. Last but not least, we have f of 10. So we have negative 10 squared plus 11 times 10 minus 5. This is going to be minus 100 plus 110 minus 5. And this is going to equal 5. So if we look at our final answers, 25 was the highest value we had. So the answer should be G, 25. And that is number 28. Next one. All right, this next problem, it was a real doozy. Let's think about this. It says, which of the following is an equivalent expression to this? And if we notice here, we know we're going to have this as a common factor, but we have to figure out what all the terms are that we're going to be factoring out. And we have to note that this is not square root, these are cube roots. So we have to figure out what both of these are going to be for a perfect cubed. So I'm actually going to start by doing factor trees for 81 and factor trees for 24. 81 is going to be 9 times 9, which is 3 and 3, and 3 and 3. 24 is 2 and 12, which is 2 and 6, which is 2 and 3. Now, if you notice, we have 3 times 3 times 3, and we have 2 times 2 times 2. So whenever we rewrite these, we know we're going to be factoring those out. So for this first one, we're going to factor out a 3, and then we're going to have the cube root of 3 underneath. We still have to figure out the variables. And for the variables, we actually want to factor out any number that has 3. So for example, x to the 4 can be split up into x to the 3 times x. And then if we actually are taking the third root of x to the third, that's just going to be x once we factor it out. It'll eventually just be x. So let's break this up into terms like that. Y squared is just going to be stay y squared. We can't pull anything out. And then z to the 12th, we're actually going to be able to pull out quite a bit. It's actually going to be 12 divided by 3. So we're actually going to be able to pull out a z to the 4th, if that makes sense. But for now, I'm just going to keep it as z to the 12th. And then we're going to do plus the 24. We know we're going to pull out a 2. And then we're going to have a 3 again. Is it a 3? Let me look at this problem real quick. Ooh, I didn't pick the right answer. They don't both have 3s. Oh no, yeah, we're doing it right. Yep, it's going to be a 3 underneath again. And then we're going to have basically x to the third, and then x times y squared. And then again, z to the 27th. Eventually, we're going to divide this by 3 and factor it out, because 27 divided by 3 is going to be 9. So let's just see if we can write this a little bit more simply now. So we have, let's write the first one. We have 3, and then times the cube root. The 3's here. Actually, we have 3. We're going to pull out one of these x squareds. That's just going to be x. So we don't have to write that term. So it's 3x y squared. And then for the z term, it's actually 12 and then divided by 3 to pull it out. So this is actually going to be z to the 4th, like that. And then we're going to do plus 2 . Yeah, I'm going to put a line through that to make sure that we know that it's a z, because my 2's and z's are looking similar. All right, plus 2. And then we're going to do our radical. I'm going to leave a little space so we can fit in our variables. Of 3. We have 2x to the 3rd. So if we're factoring out x times x, that's going to be x squared. Then the y squared is going to stay underneath. Oh, we actually have one more x I forgot about. We factored out the x squareds, but we have x. We still have the y squared. And then 27 divided by 3, this is actually a third root, it's important to write, is going to be z to the 9th. Like so. So now since these are matching, we can actually write this as 3x z to the 4th plus 2x squared z to the 9th times the cube root of 3xy squared. Like that. And let's see if that matches any of our answers. And it looks like it matches answer A. So the answer to number 25, and the answer to number 29 is A. And we'll move on to number 30. All right. Number 30 says, look at the Venn diagram shown below. The universal set consists only of sets P, Q, and R. So this is set P, Q, and R. So for example, P is this one, Q is this set, and R is this set. I don't know if there's going to be that many Venn diagram questions on there, but we'll go over it just in case there is. There's going to be a couple questions from like a data analysis, which this would fall under. But I wouldn't focus a lot of your time and energy figuring out the Venn diagrams if you're got other stuff that you need to focus on more. I actually had to look up what some of these terms here meant. So this little squiggly line normally means that would be like is similar to something, but in terms of these Venn diagrams, it's actually called the complement of P, but that basically means not P. But it does include, so this would be, it's not P, and it also includes set R. So not P, but is R. So if we circle P, we know that it's not P. It's not any of these, right? So that means it has to be in this set here. But it's not P, but it does include all of the values in R. So it does include all of the values in R, which are these two. Not P, but includes R. So not P, but includes R would just be these ones here. So that actually eliminates C and D. But then it also says minus Q. So we're going to subtract any of the ones that are in here. So that actually eliminates these ones. So the only ones that we have left are F and G. So the answer was I. That's as simple as I can explain it. Again, I wouldn't spend too much time worried about this, but that's how you do the problem. Number 31. It says, what is the value rounded to the nearest tenth of the larger root of the equation? 3x squared minus 16x plus 2. All right. So, again, we have to think before we start the problem, how do we solve this problem? We know that this is a quadratic equation, and we know that it is in standard form. Right? So standard form of a quadratic equation is ax squared plus bx plus c equals 0. So we're already in standard form, so we have that going for us. It says that the value is going to be rounded to the nearest tenth. That tells you that the factors aren't going to be nice and even. So we're probably not going to be able to use the AC method to find good factors. The leading coefficient, which is the 3, is an A, but I'm not even going to try and factor this with the EOC method. I'm just going to go straight to the quadratic formula because I know it's going to be something we're going to have to round. So let's list what A, B, and C are. A equals 3, B equals negative 16, and C equals 2. The quadratic formula, you don't have to memorize it because it's on your formula sheet, but it is negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. So let's plug in all of our values. Negative B. So minus a minus 16 is going to be a positive 16 times the square root of B squared. Whenever we plug in the value for B, we're going to put it in parentheses. So this time the negative is inside the parentheses, squared, minus 4 times A, which is 3, times C, which is 2, all divided by 2 times A. So that's going to be 2 times 3. And now if we just solve this, oh, it's plus or minus. I didn't put the plus or minus. If I just solve this, I'm going to get our 2 roots. I usually start by finding out what the determinant is, which is the expression underneath the radical here. If it's positive, there's 2 solutions. If it's 0, there's 1 solution. And if it's negative, there's no solution. So negative 16 squared, I can't use my calculator here, but negative 16 squared is going to be 256. And then negative 4 times a positive 3 is negative 12. Negative 12 times 2 is negative 24. 256 minus 24 is going to be 232, right? A positive 232. So we know there's going to be 2 solutions. 2 times 3, that's going to be 6. So let's rewrite this as a more simplified answer. So we're going to have 16 plus or minus the square root of 232 all divided by 6. The square root of 232 is 15.2 something. But it said to round to the nearest tenth, so I'm just going to do 15.2. Oh, if you're doing square root in your calculator, you're going to want to use this button right here. So you would actually type in 16. I don't want to do it right now because it might clear my stuff. But you would do 16, and then you would hit square root equals, and then it would tell you the answer. This button right here could also do square root. You would do 16, then you would hit the second button, and then you would hit this button right here, equals, or no, this button right here, second, this button, then you would hit 2, equals. If it was a cubic root, you would have hit 16, second, this button, 3, and then you would have hit equals. Because if you see, this is the root for some value of x, or a radical for some value of x. All right, so that explains how to use the calculator. So in this case, we have plus or minus 15.2 divided by 6. So the 2 roots, one of them is going to be x equals 16 plus 15.2 divided by 6, and the other one is going to be x equals 16 minus 15.2 divided by 6. If you punch the first one into the calculator, you're going to get 5.2. The second one, 0.1. You might have a couple other digits, but again, it says to the nearest tenth. So these are our 2 possible answers. But if we look at what it asked, it says the larger root of the equation. The larger, 5.2 is greater than 0.1. So in your box, you would put your answer as 5.2. And that's the answer for number 31. All right. Close out of that. Number 32. I don't know how much room I have for this one. We'll just solve this one quick. This one's a little bit confusing, but it's actually not super hard. So it says Nicky has a total of 89 coins in nickels, dimes, and quarters. He has 8 more dimes and nickels and 2 1/2 times as many quarters as nickels. In dollars and cents, what is the total value of coins? So I'm going to start out by doing nickels plus dimes plus quarters equals 89, right? And then we actually have one equation with 3 unknowns. We're trying to find how many nickels we have. So we want to write dimes and quarters in terms of nickels and then substitute those into the equations. So it said that the number of dimes that we have is going to equal the number of nickels plus 8. And then the number of quarters that we have is going to equal 2.5 times the number of nickels. So if nickels is 1, we have 2.5 times as many quarters. So if we have 1 nickel, we have 2.5 quarters, right? So we plug a 1 in. So that does make sense with what it's saying. Whenever I actually tried this problem on my own, I actually wrote that backwards. But this is the proper way to write it. So that one actually confused me for a second whenever I was solving it. So what we want to do now is we want to replace D with this term here. We're going to substitute that in, and then we're going to substitute this in for Q, and we'll have one equation, and the only unknown will be N. So whenever we write that out, we have nickels plus N plus 8 plus 2.5 N equals 89. And then if we add this up, we're going to have 1N plus 1N plus 2.5N, which is 4.5N. We're going to subtract 8 from both sides, so this is going to equal 81. Whenever we do 81 divided by 4.5, we get the value of, I think it's 12.875. 12.875. So we would put 12.875. Now, does it say in dollars and cents? Oh no, we are not done yet. We are not done yet. Why did I just jump straight to the answer? 32. Oh, I was looking at the answer for number 33. Sorry, this is not the right answer. I can't use my calculator, so it gets a little confusing. So to get the number of nickels, oh, 81 divided by 4.5 is just 18. Sorry, I was thinking way too much. So now we know the number of nickels, but we have to also determine the number of dimes and quarters. So the number of dimes is going to equal 18 plus 8, which 18 plus 8 should be 26. Yep, we have 26 dimes. And then the number of quarters, I'm just switching to a capital Q, equals 2.5 times N. So 2.5 times N, 2.5 times 18 is going to be 45. So then we have to determine out what is the value of all of these. So 18 nickels is going to be $0.9. 45 quarters is going to equal $11.25. And 26 nickels is going to be, 26 dimes is going to be $2.60. So to get our final price, we have to do the value of the nickels, which is $0.9, plus the dimes, which is $2.6, plus the value of the quarters, which is 11.25. And whenever we add all those together, we should get 14.75. So $14.75. All right, that is the answer to number 32. And let's move on to number 33. So what is the value of x in the following proportion? Now this looks a little bit weird having x minus 5 and x plus 4 on the bottom, but let's just say we had 5 equals 2 divided by x, and we were trying to get x to the top. We would actually want to multiply both sides by x, right? Because x divided by x is 1, so then we would have 5x equals 2. We're doing that same thing here, where we're actually going to have to multiply. Let me make this a little bit bigger, if I can. Let's solve for x. Yeah, that'll be a lot bigger. So whenever we solve this, we're actually going to multiply both sides by x plus 4, because that's going to cancel those out. So this is times x plus 4. And then for the x minus 5, we're actually going to multiply both sides by x minus 5 times x minus 5. Now in this case, these cancel out, and in this case, these cancel out. So we're actually going to have 7 times x plus 4 equals 15 times x minus 5. That's the first step. That's actually the hardest part of this problem. Usually you actually know that you can multiply the cross of these whenever you're solving for a variable. So it's going to be 7 times x plus 4 and 15 times x minus 5. I can just look at it and I see that, but if you don't, you'll have to do it the way I showed you the first time. And from here, it's pretty easy. We just have to distribute the 7 and distribute the 15. 7 times x is 7x. 7 times 4 is going to be plus 28. 15 times x is 15x. 15 times negative 5 . 15 times negative 5, we have 15, 30, 60, 75. So this should be minus 75. And then from there, we have to get the x's on one side, and we have to get the numbers on one side. I think in this case, it's going to be easier to bring the 7 over, so we're working with positive numbers. So I'm going to do minus 7x, minus 7x, and then I'm going to do plus 75, plus 75. So for the numbers 70, 80, 90, I think it's going to be 103 equals, these cancel out to 0, 15 minus 7 should be 8x. So we have 103 equals 8x. We're going to divide both sides by 8. 103 divided by 8 should be our answer. I don't have any of this written down, so I have to see if I'm right. So I'm going to clear this. 103 divided by 8 equals 12.875. That was correct. So in our box here, the correct answer is 12.875 for number 33. And we'll move on to the next problem. This one, it looks like you would actually be calculating the slope because you have a table, but it says George is training for a marathon. The following chart shows his time in hours and distance for the run in miles for 4 days. On which day did George have the highest average speed? So speed, you have to think, is it going to be time divided by distance or distance over time? Distance is usually like meters per second, or in this case, it's miles per hour. So the distance is on top. So we're going to do the distance divided by the time. And we just have to do it for each row. So for the first one, we're doing 12 divided by 1.5, which is 8 miles per hour. And then 15 divided by 2 is going to be 7.5. 26 divided by 3.5 is 7.43. 5 divided by 0.6 is 8.33. And it asks for which one has the highest average speed. So we're looking for the biggest number. The biggest number is here, which was on Thursday. So the answer to number 34 is Thursday. And we will go to the next one. If I remember right, this one was a little bit weird. Yeah, I actually couldn't solve this one whenever I looked at it, and I think it's because they didn't give you enough information. They have to tell you 12 miles in 1.5 hours. So the first 12 miles he ran in 1.5 hours, and now we can solve it. So first we have to figure out what was the time that it took to run 3 miles at 9 miles per hour. So for this one, our slope, which is usually change in y divided by change in x, in this case, it's going to be distance over time. So we actually have 3 miles at 9 miles per hour, and that's actually going to give us time. So that's going to be 0.33 hours. And then we're going to take the total distance, which the total distance was 12 miles plus 3 miles, which is 15 miles, divided by the total time, which is going to be 1.5 plus 0.33, which is going to be 1.88 hours. And this is going to be times x, which is going to represent the number of hours. So this is slope is representing the distance, and then the x is representing the number of hours. So 15 divided by 1.88 is going to be 8.18. Wait, why am I writing? Yeah, this is the slope. So no, our final equation, this is the slope, which we plugged in here. This is going to be y equals 15 divided by 1.88x. So then that's actually going to be y equals 8.18x, like that. Again, that question was a little bit weird, but that is how you do it. Number 36. This is a really good question. I didn't like the last question that much. This question I like, so make sure you understand how to do this one. So whenever you look at this, you have to realize this is a quadratic equation, and it is in standard form. So standard form is y equals ax squared plus bx plus c. So in standard form, we know two things. So whenever you do your brain dump and you write everything down on your formula sheet, you have to know that c equals the y-intercept. And we know that the x-coordinate of the vertex, which is also called the axis of symmetry, equals negative b divided by 2a. So let's start with the y-intercept. We know the y-intercept is going to be 9. This one has a y-intercept of 3, not going to be the answer. This one's going to have a y-intercept somewhere down here, which is going to be a negative number. So we're going to have a negative y-intercept. This one's positive 9. It's not going to be this one. This one looks like it could be coming up to 9, and then this one looks like it could be coming up to 9. So it's going to be answer H or answer I. But the question is the axis of symmetry here, or is the axis of symmetry here, or the x-coordinate of the vertex? So we have to determine if it's going to be negative 3 or positive 3. And all we have to do is plug it into this equation. So x equals negative b. So our b was 6. So we have negative 6, all divided by 2a. Our a, the number in front of the x, is 1. So it's just going to be 2 times 1, which is 2. Negative 6 divided by 2 is negative 3. So our axis of symmetry is going to be right here. X equals negative 3. That's this linear equation for the axis of symmetry. Our answer is H. That was a good question. I liked it. Next one. This is another good question. This is basically a FOIL question, but they don't want to just directly give you a question, hey, use FOIL to solve these two binomials or multiply these two binomials. So it says the area, you're supposed to know area equals length times width for a rectangle. This is the length, this is the width. So area equals 4x plus 5. and you're going to multiply that by 2x plus 3, and it looks like that's going to be it, but let's multiply it out and see. So we're going to have 4x times 2x, which is 8x squared, and then 4x times 3 is going to be plus 12x. 5 times 2x is plus 10x. 5 times 3 is plus 15. We have to combine like terms. 8x squared plus 22x plus 15. And yeah, that matches this exactly. So the answer is D. That one was easy. Next one. All right, this one is actually a really, really good question. Usually, anytime I've ever solved absolute value problems, it was actually for a number that was equal. And how you normally approach that problem is you get the absolute value on one side. So if there was like a 2 over here, you would divide both terms by 2 so that you only have the absolute value on one side and then just a single number or any other term on the other side of the equation. But usually it's just one number. And then what you do is you just make the right-hand side of the equation plus and minus 7, like this. So you just have minus 5x plus 2, and then in this case we have this inequality is plus or minus 7. The only difference is whenever you have this inequality and you plug in a negative sign, you actually do have to flip the inequality. Let me try and get back to where we were. I'm not sure why that moved. Oh boy. Here we go. All right. Yep, there we go. So whenever you actually do the negative, you also have to flip the inequality to the negative 7. So that's what we're going to do. But first, let's just solve it and see if we can actually pick off one of these answers right off the bat. So the first thing we do is just ignore the absolute value sign and we make it a positive. So we have minus 5x plus 2 is less than 7. And we have to solve for x. We solve it just like it's an equal sign. This is an inequality. We can treat it just like an equal sign unless you multiply or divide both sides by a negative sign. Then you flip the inequality. So we're going to do minus 2 from both sides. So negative 5x is less than 5. We're dividing both sides by negative 5. So we have to flip the inequality. Negative 5 divided by negative 5 is 1. 1 times x is just x. 5 divided by negative 5 is negative 1. So this is the first solution to the absolute value problem. X is greater than negative 1. X is greater than negative 1. That works. X is less than negative 1. That one doesn't work. X is greater than 1. That doesn't work. X is less than 1. That one doesn't work. We actually know the answer is F, but for completion, let's solve the other one too. For the other one, we're going to have negative 5x plus 2, and we're going to flip the inequality because we're making it negative, equals negative 7. Now we're going to solve it the same way. Plus 2, we're going to minus 2 from both sides, so negative 5x is greater than 7, 8, 9, negative 9. And then we're going to divide both sides by negative 5, which means we have to flip the inequality. So x is less than, since these are both negative, a negative divided by a negative is just going to be written as a positive. So x is less than 9/5. And if we can see, that's what this says here. X is less than 9/5. So the answer to this problem is F. All right. Yep, that's how I would solve that one. Let's go on to number 39. Okay, this is a great question. We don't have much room to show our work, so I'll solve the slope here, and then I'll solve the rest of it down here. So it says, what is the y value of the y-intercept of a line that contains these points? So first, we're going to have to determine the slope, and then we're going to have to write it in point-slope form, and then we're going to have to plug in x equals 0 whenever you're solving for the y-intercept. So once we have the equation in point-slope form, we're going to plug a 0 in for x and solve for y, and that's going to be our answer. So first, let's find the slope. M equals y2 minus y1 over x2 minus x1. So I'll call this x1, y1. I'll call this x2, y2. Once you have that set up, it's not too bad. So it's going to be 67 minus a minus 5 divided by negative 8 minus, oh wait, x2. I almost messed up. Make sure the first part's right. Yeah. So it's going to be 10 minus a minus 8. So that's going to be plus 67 plus 5. You get 73. I'm just going to double check that I got the same answer I did before. Oh, 72. See? Good thing I checked. 72. And then 10 plus 8 is going to be obviously 18. And then we have to do 72 divided by 18, which is going to equal 4. So m equals 4. So now I'm going to use, which one am I going to use as my first point? I'm going to use this one as my first point. So I'm going to write, obviously, y minus y1 equals m times x minus x1. Again, we're never going to plug in a value for the x and the y. This is x1 and y1. So we have y minus a negative 5. So this is going to be a positive equals the slope, which was 4, times x minus a negative 8. It's going to be a plus 8. And again, we're going to plug a 0 in for x. So if we plug a 0 in for x, we're just left with 8. So we have y plus 5 equals 4 times 8, which is 32. We're going to subtract 5. So y equals 32 minus 5, which should be 27. 27, and that is our final answer. So it says, what is the y value? We're just going to put 27. And that's how you do number 39. All right, so we're about an hour and 40 minutes in, hour and 43, and now we're on question 40. How many pounds of peanuts worth 60 cents per pound should be mixed with 27 pounds of cashews worth 90 cents a pound to create 45-pound mixture worth 78 cents per pound? All right. So here's how I did for this one. We did peanuts times 0.6 plus 27 pounds of cashews. So what was cashews, right? Yeah, times 0.9 is going to equal 45 pounds total times 0.78. And all we have to do now is solve for p, and we will get our answer. So I'm going to write this as 0.6p plus 24.3 equals 35.1. Now we're going to subtract 24.3 from both sides. So we have 0.6p equals 10.8. Divide by 0.6, divide by 0.6, p equals 18. And that should be the answer for number 40. So we're just going to put 18 as our solution. And we're done with number 40. 41. So if we look at this, we know that we have a quadratic equation, and it's in standard form. So we have ax squared plus bx plus c equals 0. We know that our a is 2. So we could use the quadratic equation, but that actually wouldn't work. We can't use the quadratic equation because it's not actually asking us for the solution. It's asking us for which one is a factor. So if we found the solution, you'd actually have to work backwards to see which one of these, if you set it equal to 0, would equal that solution. One of the solutions. That could work, but the better thing to do would be just to factor this using the AC method. So let's list what A is. A equals 2, B equals 9, C equals negative 35. And whenever we do this, we find something that multiplies to A times C and adds to B. So A times C is going to be negative 70 because we do 2 times negative 35. And then it has to add to 9. And if you list out all your factors, the factors that work are negative 5 and 14. So if you guys are wondering how to do that, what you do is you just start listing your factors of negative 70. So for example, you'd have like negative 7 and 10. You could also have 10 and negative 7. It's divisible by 2, so you could do like 2 and 35. But since it's divisible by 10, it's also divisible by 5. So that's where you would do 5 and 14. And then you have to think which one of these should be negative or positive to make it add to 9. And you would want that 5 to be negative. So these would be your two factors that you put in there. And then in this case, we're actually going to be splitting up this middle term into these two factors. If it wasn't the AC method and A equals 1, these actually would be your factors. You would just write like x minus 5 times x plus 14. But this isn't a case where A equals 1. This is the AC method. So you actually have to break up the middle term into the two factors. So we have 2x squared minus 5x plus 14x minus 35. Now we have 4 terms and we're going to solve this with grouping. So we have to figure out what is the greatest common factor of this term and this term, and we're going to factor out the GCF for both terms. And this time 2 and 5 are both prime numbers, so we can't factor out a number, but we can factor out the variable with the smallest exponent, which is just x. So we're going to pull out an x, and this is going to be 2x minus 5. And then for this one, we know that this one's going to match this one, so we're going to have to pull out a 7. So that's going to be 2x minus 5. And now we're pretty much done. One of the factors is this one, and one of the factors is this here, x plus 7. So we have x plus 7, and we have 2x minus 5. And again, it didn't ask us for a solution here. It asked us for a factor. That's very important. So x plus 7, that was one factor. And if it said pick all of the factors, there could be more than one. But it looks like this one doesn't work because it says plus 5. This one doesn't work. This one doesn't work. So that is the answer because it said factor. If it said the solutions, our solutions would be x equals negative 7 and x equals, you'd bring the 5 over and it would be 5 divided by 2, which equals 2.5. That would be the solutions or the x-intercepts or the roots if it asked for that. But again, it didn't. It asked us for the factor, which is why that was the answer. All right, let's do number 42. Oh, a Venn diagram, great. That's what I would think. The Venn diagram seems silly. I don't even really consider it algebra, but it's just like, it's almost like a logic test more than anything. So it says there's 55 elements that do not belong to either set A or B, but do belong to the universal set. So the universal set has 55 numbers that aren't in either of the A or B circles. And it says a set containing 72 elements, set B contains 51, so this one contains 51, and set A contains 72, and it said, and U contains 168 elements, 168 for U. And it said, how many elements are there in set A and set B? So let's just add up what we have here. We have 72 plus 51 plus 55. That's actually going to equal, I think it equals 178. Yeah, it equals 178. So if you add all these up, it's 178. But the total is actually only 168, which means that 10 of these numbers in set A and B were repeated. So how many elements are there in set A and set B? So how many elements are in set A, are both in set A and set B? So basically, how many duplicates were there? And I'm pretty sure the answer is 10. I'm gonna go double check that real quick, but I think it's 10. Number 42. Oh wait, yeah, 42. Yeah, thus x equals 10. So the correct answer is 10. That was correct. Let's go on to number 43. Danny wishes to solve this equation. Which of the following would be the correct step in solving this equation? I'm not gonna lie, the first time I solved this, I got it wrong. And it's because this is a quadratic equation, but it's not in standard form because it does not equal 0. So I just solved this and I assumed that this was 0, which was really silly. So before you start solving, don't just rush through the test. Look really careful to make sure that you're in standard form before you start. So we have to subtract 4. So this is actually going to be x squared plus 7x. You have to subtract 4 from this side, so this is going to be plus 6 equals 0. And now our leading coefficient is 1. So we can factor this without using the AC method, just using the normal method, where we have to find something that multiplies to C, which is 6, and adds to 7. The factors there are going to be 1 and 6. And that's actually the factors. So we just have x plus 1, and then we have x plus 6. And this is the factors. And this time, we're actually looking for the factors. We're not looking for the solutions. And this one matches. But it's actually reversed, x plus 6 and x plus 1. But those are the same thing. So the answer is, in fact, C. Yeah, if you multiply these out using FOIL, you're going to end up with the same original expression, which would actually be a good exercise to do. So 43, moving on. Number 44. This one should be a really easy question. So whenever you have divided by, this term is divided by the bottom number and this term is divided by the bottom number. So all we have to do is our exponent laws. If we're dividing, we're subtracting the exponents. So m to the 9, let me actually make this a little bigger so you guys can see it real well. All right, so yeah, m to the 9 divided by m to the 3 is going to be m to the 6. It's 9 minus 3. So 9 minus 3 is 6. That's how we got this 6. And then we're going to do 16 minus 4. So that's going to be m, oh wait, no, not m, next variable, p to the 12. So that's this first term divided by this term. That's done. Now we're going to keep this minus sign, and now we have to do this term divided by this term. 6 divided by 3 and the exponents is going to be m to the 6 minus 3, which is 3. 12 minus 4 is going to be p to the 8. And that should be it. Let's see if one of them matches. Yeah, it looks like answer G matches. So we are good. Next one, 45. Moving on. All right, Charlene will write this expression as a to the x, b to the x. And then it says, what is the sum of x and y? So it wants us to solve it, and then for the answer, it actually wants us to do x plus y. And that's the number that we're going to put in the box. So the first thing we have to do is distribute this -2 times all of the values. So whenever you're distributing, you're actually multiplying. So this is going to be negative 13 times negative 2. So we're going to have a to the 26, this is an a, and then we're going to have b to the 14 divided by a to the positive 10, b to the negative 20. Yep, that looks good. And then we're going to use exponent laws. We have to do 26 minus 10. So we have a to the 16, a to the 16, b. 14 minus a negative 20. That's going to be b to the 34. So this is the simplified form of this expression, but it asks for what is the sum of x and y, and it's saying that this is x and this is y. So we have to do 16 plus 34. 16 plus 34 equals 50. So in our box, we have to put 50 as the final answer. So that was just a little bit weird that they asked us to sum the exponents at the end, but other than that, it was pretty straightforward. Next problem. This one is, again, it's kind of a logic test more than anything. It's not something that you just like commonly do in algebra, but we'll go through it. All right, so it says you are given a universal set of all natural numbers up to 30. Suppose m is a set of all multiples of 5, and n includes all even numbers between 11 and 21. For which of the following sets does all of its elements belong to neither m nor m? So the first one, we're going to do m times 5. We can list all those. Well, m times 5 up until 30. And then we're going to do n is even between 11 and 21. So this set here is going to be 5, 10, 15, 20, 25, and 30. The next set is going to be 12, 14, 16, 18, and 20. And then it says all of the elements belong to neither one. So if we look at this one, 15's included. If we look at this one, 10's included. If we look at this one, 5 is included, so that's out. Let's look at this one. 6, 8, 11, 22, and 27. None of those are in either of these two sets, so the answer was G. Again, I think it's a little bit of a strange question, but that's what you were supposed to do. Number 47. It says, what is the slope of a line that's perpendicular to this line and contains these points? So the slope of a line that's perpendicular to the line that contains these points. So all we have to do is find the slope, and we just have to do the opposite reciprocal. So let's calculate the slope. So m equals y2 minus y1 over x2 minus x1. We'll label the points. I always do this just to make sure that if you get confused, which one's which. x1, y1, x2, y2. But it's always this one minus this one, and then that one minus that one. So 9 minus 4, 9 minus 4, and then negative 7 minus 5. 9 minus 4 is going to be 5, and then this is going to be negative 12. So the opposite reciprocal of that is going to be a positive 12 divided by 5. And again, in this case, this is an exact solution, 12 divided by 5. But if you actually type in 12 divided by 5 in your calculator, you get 2.4. And the decimal doesn't continue. This is a terminating decimal. So this is actually an exact solution for the slope as well. So I think either one of these would be valid answers. And now we're at 48. So we're basically 2 hours in, and we would almost be done if the questions were only 50. But of course, we got to do 65. says, which of the following graphs represents a line with an undefined slope? I don't even remember this one. 48 with an undefined slope. Oh, yeah, I do. So for this one, what is the slope? This one, the slope is actually 0. For this one, as we go from left to right, the slope is decreasing. So the m is negative. There's not actually numbers on here, so we don't know. This one, as we go from left to right, we're increasing. So the slope of this one is going to be positive. For this one, this is the one where m is undefined. Yep, m is undefined, so the answer is I. All right, 49. This one looks like it's going to be fun. Let's do it. Here we go. All right. So it says, Pauline works as a sales representative for a book publishing company. Her monthly salary is calculated with this formula. In this equation, S is her monthly salary and D is $1 in sales. Pauline has always managed to sell at least $6,000 worth of books each month. Last month, her salary was $2,594. So how many dollars worth of books did she sell? So we want to solve for D, and we know what her salary was. So we have one equation, and once we plug in the salary, we'll have one unknown. So we have to plug in 2,000. Let me see if I can, I guess this is fine. 2,594 equals 2,000 plus 0.18 times, I'm going to do a capital D, minus 6,000. So all you have to do is solve this and we'll get the answer. So the first thing I'm going to do is we should distribute. That's one thing we need to do, and we need to subtract the 2,000. So minus 2,000. So in this case, I'm going to write it here. We have 594 equals 0.18 D, because we did 0.18 times D, and then 0.18 times 6,000. Well, I did it a little bit differently before, but this will still work. Hopefully, let me just grab a calculator real quick, because if I use this calculator, it's not going to work. So I have to do 0.18 times negative 6,000. So that equals negative 1080. So then to get rid of the negative 1080, we're going to have to add 1080 to both sides, plus 1080. So 594 plus 1080 is going to be 1674, which equals 0.18D. To get rid of the 0.18, we do 0.18, divide both sides by 0.18. This is just going to give us D on this side because that equals 1 times D. And then 1,674 divided by 0.18 is 9,300. So for number 49, the answer would be 9,300. And that's it. That's the answer to number 49. Number 50. What is the reduced form of this fraction? Okay, this one, you can't just do x squared minus x squared. The heck? I didn't even think I hit anything. All right, for this one, we can't do like x squared divided by x squared. This is actually a little bit different. So we actually have to factor both of these and see which factors cancel out. So first we have to factor, let's see if I can, yeah, here we go. We can factor x squared minus 7x minus 30. So we're going to use, we don't have to use the EOC method, we can just factor this with the basic factoring method. We have to find something that multiplies to negative 30 and adds to negative 7. And that is going to be 3 and negative 10. So that's going to be x plus 3, and then we're going to have x minus 10. So that's what we're going to have on top, x plus 3, and we're going to have x minus 10. X minus 10, and we're going to divide that by, let's use the AC method for the next one. We have 2x squared plus 7x plus 3. We have to find something that multiplies to a times c, which is 6, and adds to 7. So multiplies to 6, adds to 7, that's going to be 1 and 6. So we have 2x squared plus x plus 6x plus 3. Then we have to factor this by grouping. We're going to pull out a x. This is going to be 2x plus 1. And then we're going to pull out a 3. And this is going to be 2x plus 1. So our factors here are going to be x plus 3 and 2x plus 1. So let's write that here. Now we have x plus 3 and we have 2x plus 1. So now we can actually cancel out these x plus 3 and x plus 3 because that equals 1. So our final answer is going to be x minus 10 divided by 2x plus 1. Let's see if that's any of the ones. And it looks like that is in fact answer H. All right, we just got 100%, well hopefully 100%, on our 50 question EOC. But let's do the other 15 questions for more practice. So let's keep going. Consider this relation. How many different values could x assume so that this relation is not a function? How many values could x assume? I don't even remember this question. Oh, so it's not a function. I got it. So in order for it not to be a function, the x values have to be the same, right? So on our formula sheet, if we have points like this, 0, 7, x is 0, you'd have some point up here, and then you'd have 1, 7, and you'd have 7, 1, 8, 2, and then some value, 9. You just can't have any points that match these 4 points in the x. So we just can't have this value for x, this value for x, this value for x, or this value for x. So that would be 4 cases that you can't have. So the answer is just number 4. It's just testing whether you know that you can't have the same value of x for it to be a function. And that's how you do 51. Next one. What is the simplified form of this expression? All right, so if you look, the operation that we're doing for these radicals is minus and plus. So that means we have to have the same number under the radical, and then we can add or subtract the numbers in front, and we can just keep the radical the same. So it looks like the number underneath that we're going to have in common is going to be 3. So I just like doing the factor trees. It makes sense to me, and then I just pull out as many as I can. So I'm going to do 3 factor trees for this, 12, 27, and 192. So for 12, well, actually, no, I'm not going to do that for this one. It's easier because I know that I'm going to have 3 underneath, so I'm actually going to just divide all of these terms by 3. You could do the way that I said before, but 12 divided by 3 is 4. So I'm going to have 4 times 3x minus 4. 27 divided by 3 is 9, so I'm going to have 9 times 3x plus 5 times the square root of 192 divided by 3 is 64 times 3x. So now I'm going to pull these numbers out. So the square root of 4 is 2, so I have 2 times the square root of 3x minus, I'm going to pull out a 3. So this is going to, the square root of 9 is 3, so negative 4 times 3 is negative 12, plus, whenever I pull out a 64, it's going to be an 8, so 5 times 8 is 40 times the square root of 3x. Oop, I forgot to write my square root of 3x here. So now all I have to do is add and subtract the numbers in front and leave the square root of 3x, the square root of 3x. So 2 minus 12 is going to be minus 10 plus 40. This is going to be 30. So 30 times the square root of 3x. The answer is F. All right, next problem. Number 53. Given this equation, which of the following is the correct expression for R? All right, this is going to be a good one. So now we have to solve for R, and if we see that it's actually underneath a radical. Ooh, this problem actually did trick me up a little bit, but I do know how to solve it. So solving for R, the first thing we have to do is subtract 3q. So minus 3q minus 3q. So we have p minus 3q equals negative square root of R divided by 4. To get rid of the divided by 4, we're going to multiply both sides by 4. So now we have 4 times p minus 3q equals negative square root of R. Now I tried dividing everything by negative 1. So this would actually be like a negative 4, and then it would be the square root of R. But that's not what they did. That's not what the solution says. What they did is they took the square root like this. So a negative times a negative is a positive, and then the square root squared, the only thing we have left with on this side is R. And since we squared this term, we also had to square the other side. So then we just got 4 times p minus 3q, and then this whole expression was squared. So the answer was answer A. Again, this negative outside of that radical there was a little tricky. I personally was a little bit confused by it when I did it the first time. But that's how the solution manual said to do it, so that's how you do it. Number 54. Whoops. This one looks like it's going to be a fun one, actually. I like it. All right, so what is the sum of this trinomial and this trinomial, and then you have to subtract it by this trinomial. So the first thing we're going to do is add these two trinomials together. So this is a plus sign. 9x minus 6x is 3x squared. Negative 2x plus 8x is plus 6x. And then 3 plus negative 13 is minus 10. And then we have to take this trinomial and we have to subtract it from this trinomial. Minus 3x squared plus 10x minus 20. Now if you want to, instead of this minus sign, you can make this positive and you can switch the sign of all of these. So this would be minus 3x squared minus 10x plus 20. And then you can just add the two expressions. That's fine. I actually just always do it like this. 3x squared minus 3x squared. That's 0. So we don't have to do anything with that. And then we have 6x minus 10x, minus a positive 10x, which is just minus 10x. And that's going to be minus 4x. Then I have minus 10 minus a negative 20. Minus a negative 20 is a positive. So we have negative 10 plus 20, which is going to be plus 10. So it should be negative 4x plus 10, which is answer F. Yeah. So that was adding trinomials, and we actually had to then subtract trinomials. So it was kind of a compound problem. Oh, I heard somebody else here. All right. Let's look at number 55. Is this thing still recording? Yep, so we're 2 hours and 15 minutes in. This is a good review. It says a universal set U contains 20 elements. Set M and N are subsets of U. Set M contains 8 elements. Set N contains 5 elements. And set M and U contains no elements. How many elements are in the Cartesian product of not M times N? All right, so that sounds like a bit of a twist, right? So if we read here, it says set M contains 8 elements. So 8 in M, and N contains 5, so 5 in N. And then we have N. So we know N is going to be a 5, right? So N is going to be 5, and we have to figure out how many are in M. In M, it equals 20 minus 8, which equals 12. And then this equation, not in M. So not in M equals 12. So then we do 12 times 5, which should equal 60, right? Is that the answer? I think the answer is 60. Let's look real quick. That one might take a little while to wrap your head around. You might have to read it a few times. Number 55. I'm just making sure the answer's right that I gave you. Yeah, it says 60 elements. The correct answer is 60. All right. I'm not going to spend too much time on that one. That one, again, it's kind of a weird one with these sets and not symbols. Hopefully they don't give you one like that on your test. It says 2 hot dogs and 5 soft drinks cost $8.50. 5 hot dogs and 2 soft drinks cost $14.95. In dollars and cents, what is the cost of 3 hot dogs and 3 soft drinks? All right, so this one was actually quite a bit of work to solve, but let's get to it. So we actually have 2 hot dogs plus 5 drinks equals $8.50. And then we have, as a separate equation, 5 hot dogs plus 2 drinks equals 14.95. So we have 2 equations and 2 unknowns. So we have to solve for one variable and then plug the common variable into the other expression. That's the approach. So the first thing I'm going to do is I'm going to solve for d on this equation. So I'm going to subtract 5h. I have 2d equals minus 5h plus 14.95. And then I'm going to divide by 2. So divide both sides by 2. D equals minus 5h plus 14.95 divided by 2. And now I have to plug this expression into my other expression. So I have to plug it in over here. So now I have 2h plus 5 times negative 5h plus 14.95 divided by 2. And that's going to equal 8.50. Now I'm going to have to distribute this 5 times both terms. Whenever I do that, I get 2h plus this first term. 5 times negative 5 is negative 25. Negative 25 divided by 2 is negative 12.5h. And then for the other term, it's going to be 5 times 14.95 divided by 2, and that's going to equal 37.375. And all of this is going to equal 8.50. So now I have to combine my h's. So I have 10 or negative 10.5h equals, I'm going to subtract 37.375 from both sides. And then 8.5 minus 37 is going to be minus 28.875. I'm going to divide both sides by negative 10.5 divided by negative 10.5, and I get h to equal 2.75. So that's the hardest part. Now that I have h, I can plug that value into either equation to get the price of the dogs. So I'm going to plug it into this equation here. So I have 2 times 2.75 plus 5d equals 8.50. So this is going to be 5.5 plus 5 drinks equals 8.50. I'm going to subtract 5.5 minus 5.5. So I have 5 drinks is going to equal 3. Divide both sides by 5. The price of the drinks is 0.6. So now I have the price of the hot dogs, which is $2.75, and the price of the drinks, which is 60 cents. And now I have to plug it into the equation where I have 3 drinks and 3 hot dogs, and I have to find the total. So I do 3 times 2.75 plus 3 times 0.6. And whenever you get that, your total price is going to be 10.05. So in your box, you would put $10.05. But make sure, see if it needs to put $sign or don't put $signs. And then if it's in dollars and cents, you're never going to want to include another number here. You're going to want to round up to the nearest cent. But we didn't even need to round anything. It was exactly 10.05. That was one of the longer problems. The solution showed a slightly easier way to do it, but the only sure way to do it is to actually substitute the equations when you have 2 equations and 2 unknowns. So that's why I showed it this way. We'll close it. Number 57. So it says, which of the following represents the graph y equals ax squared plus bx plus c, in which a is less than 0 and c is greater than 0. So in this equation, c we know is the y-intercept. So we know the y-intercept has to be greater than 0. This one, the y-intercept is right here, not greater than 0. This one, the y-intercept is negative. It's not going to be this one. This one has a positive y-intercept, and this one has a positive y-intercept. So we know it's going to be A or C. The next thing that tells us is that the A value is less than 0. Less than 0 means it's a negative. If we have a negative A, we actually know that the function is going to be inverted. And we're actually going to be finding a local maximum. Whenever a is positive, you're actually going to be finding a minimum for a quadratic function. So the answer to this question, number 57, is going to be A. That was a good question. Number 58. All right, what is the sum of all of the coefficients? The coefficient, guys, is the number in front of the variable, but the constant, which at the end, that also counts as a coefficient whenever it says adding all of the coefficients. I actually wasn't positive if you would include the number, but you do in fact include the number. So the first thing we're going to have to do is distribute this -2 to all of the terms. So we have 9x cubed plus x plus 7 minus 10x to the third minus 22 minus 22x squared minus 14x. So that is the expression, but we actually want to simplify it, right? It says for the simplified form. So just because we expanded it out, we still have to combine like terms. So we have 2x to the 3 terms, and if we look here, we have an x term here, and we have a positive x here. So let's start out with the x's. 9x to the third minus 10x to the third is going to be minus x to the third. And then we have minus 22x squared. That was the only x squared term. And then we have 1 minus 14, which is going to be minus 13x. And then we have plus 7. So the coefficients are negative 1, negative 22, negative 13, and positive 7. If we just do the math, that's going to give us the answer. And if we do that, our answer is negative 29. So it's negative 29. That's the sum of all of the coefficients. All right, 2 hours and 27 minutes in, just about. Let's do number 58, or 59. Another fun Venn diagram. I don't think this one was too bad if I remember right. So number 59, in the Venn diagram shown below, for sets D and E, the universal set U consists of all of these elements. Only elements P, Q, R, and S and Z are shown in their proper regions. So P, Q, R, S, and Z are in their proper regions. And it says if set D and if these values are included in sets D and in sets E, which of the following represent the set of elements that belong to exactly 1, D, and E? So that means right in here, we're going to have T, W, X, and Y. All right? So that means these ones are definitely not going to be included in both, and these ones are definitely not going to be included in only one. So in this case, we have P and Q. These ones are good. R is not good. S is not good. T is not good. U would be good. V, I don't see V anywhere. W is bad. X is bad. Y is bad. Because look, these are in both, right? These ones. And these ones are not in either one because they're outside of it. So it's going to be P, Q, U, and V. Do we have one of those as our possible answers? Yeah. Answer C. That's the correct answer to number 59. Let's go to number 60. Ooh, this one's going to be fun. So what is the value of Mn? So that means we have to find out what M and N are, and then we have to do M times N is going to equal the answer. I think I misspelled answer. There we go. All right. So for this one, we have to take the negative 4 and we have to multiply it by all of the exponents. So that'll be the first step. So negative 3 times negative 4 is going to be 12. So we have 2 to the 12, and then times 5 to the positive 4 divided by 2 to the negative 4 times 5 to the positive 8. And now whenever we're dividing, we're going to subtract the exponent. So 12 minus a minus 4 is going to be 2 to the 16. And then that's times 5 to the 4. Minus 8 is 5 to the negative 4. So we're going to do 16 times negative 4, right? That's what we're doing. 16 times negative 4. 16 times 2 is 32. So it's going to be negative 64. Negative 64. Let's see if that's the right answer. And indeed, it is the right answer. That's what we're supposed to do. Number 61. All right, it says the equation of a line L1 is x plus 4y equals negative 2. If L2 is perpendicular to line 1, and if L2 contains this point, which of the following represents the equation for L2? So we're going to be perpendicular to this line, and it has to pass through that point. So the first thing we have to do is put that in slope-intercept form and determine the slope of L1. So to do that, we're going to have to get rid of x from both sides. So we're going to have 4y equals negative x minus 2, then divide both sides by 4. So divide this by 4 and divide this by 4. Y equals negative 1/4 x minus 1/2. That would be the equation of line 1. But we're perpendicular to that, so we have to do the opposite reciprocal. So the slope of our line is going to equal 4. And our line, L2, passes through this point. So we have a point and we have a slope. If we have a point and a slope, we're going to use point-slope form, which is y minus y1 equals m times x minus x1. Now we just plug in the values. This is, of course, x1, comma, y1. So we're going to do y minus 1 equals 4 times x minus 5. Now we're almost done. This is in point-slope form, but it doesn't, none of our answer keys are in point-slope form. They're all in slope-intercept form. So we're going to have to distribute, and then we're going to have to add 1 to each side. So y minus 1 equals 4x minus 20, and then we're going to add 1 to both sides. So y equals 4x minus 19. Y equals 4x minus 19 is answer C. All right, that one's good to go. Now we're going to do number 62, hopefully. Which of the following sets contains none of the values of x that satisfy this inequality? All right, so we don't want any of them to do it. So this is an and problem, most likely, because we have two different inequalities. So to solve this, whenever we have two different inequalities, here's what we do. First, we just ignore this one, and we solve that. So let's do that first. We have negative 4 is less than 2x plus 7. We got to solve for x, right? So we're going to subtract 7 from both sides. 7, 8, 9, 10, 11. So negative 11 is less than 2x. We're going to divide both sides by 2. By a positive 2, we do not have to flip it. So x equals negative 5.5. Or no, x is greater than 5.5. Now we're going to ignore this part of the equation, and we're going to solve that. So 2x plus 7 is less than or equal to 11. We're going to subtract 7. 7, 8, 9, 10, 11. So this is going to be a 4. 2x is less than or equal to 4. Divide both sides by 2. Positive 2. X is less than or equal to 2. So we have these two different inequalities, and what we want to do is probably plot this on a number line so that it makes it easy to see which numbers are within the set and which ones aren't. So this is 0. We're going to have a positive 2, 1, 2, and it's going to be less than or equal to this, so it's going to be going this way, and then greater than negative 5.5. So 1, 2, 3, 4, 5, 6. It's going to be halfway in between. So negative 5.5. This is an open circle here, and it's going this way. So we have an open circle, means it doesn't include that point, and then we have a closed circle at 2. So now we want to find one that contains none of the values. The first set, right off the bat, that one includes the values, definitely not it. The second set, negative 8, that's outside of it. Negative 7 is outside of it. And then positive 1, ooh, that's in it. That's not good. Next one, negative 6.5 is out, 6 is out, 5 3/4. 5 3/4 is, it's still out of the thing, and then 2 1/5, that's going to be out here. So none of these are included. And just to make sure, this next one, negative 5 1/4 would actually be in the set. So that one wouldn't work. The only one that would work is set H. All right, we've been at this for a while, over 2.5 hours. But let's keep working here. It says you are given the function. So that's a function which contains 4 distinct elements. The highest value of the range, so the highest value of the range was 16, and the lowest value of the domain was -5. If x and y, which is 2 different numbers, are both integers, what is the maximum value of the absolute value of x minus y? So the absolute value of minus y, we can actually use the same value of 16 for the y. So we're going to have minus 16, but it says that the lowest value in the domain was -5. We can't go lower than -5. And if we're assuming whole numbers, that means the lowest we can go is -4. So we have -4 minus 16, which is minus 20. The absolute value of -20 equals a positive 20. So the answer here is positive 20. That one was a little bit tricky. Some people might have just done -5 minus 16, which would have been 21, but that's not what they were looking for because they wanted you to pick new values. And honestly, it was a little bit confusing, but that's how you do it. Number 64. Oops, almost done. All right. Here we go. Which of the following represents a graph of a line whose slope has an absolute value greater than 1? So we're looking for a slope greater than 1. This one, the slope equals 0. Definitely not it. We're looking for something that is going to rise more than it goes over. So we're looking for something that's steep. And that's going to be set I. Because this one, actually we're going m equals 2 over 2. That equals 1. This one is also up 1 over 1. M equals, the rise was 1. The run was -1. So this one, the slope, as we go from left to right, it's negative, and it's going to be -1. This one was +1. This one was 0. So since these ones are all just going to be equal 1, the absolute value of -1 is just going to be +1. So this is the only one that it could be. And we can see that we're going to be, this point here, it's kind of tricky. You would think, oh, the slope is 1, but this point isn't on the line. We're actually going to be going up more than we're going over. So why they gave us this point is just to show that we are going to be rising more than we're going over. So the top number is going to be bigger, which means it's going to be bigger than 1. Even though this is a negative slope, the absolute value of a negative is still going to be a positive. So it's going to be greater than 1. Because it says whose absolute value is greater than 1. Maybe they were trying to trick people into thinking that since it's negative, it was going to be less than 1, but I think people would get that. Number 65. Bobby is given the function and calculates the value of f of 6. Diane is then asked to substitute the value of f of 6 in for x into this function. This isn't even really a transformation function. This is just, you're supposed to solve the value and then plug that value into the next formula. So let's solve it real quick. We have f of 6 equals, so we have to plug a 2 in, or we have to plug a 6 in for these x's. So we have 2 times 6 squared minus 6 minus 13. 6 squared is 6 times 6, which is 36. 36 times 2 is 72. Minus 6 minus 13. 72 minus 6 minus 13 is going to be 53. F of 6 equals 53. So we have to plug this value into the g sub x term. Now we have g of 53 equals 53 squared minus 100. So if you do 53 squared, it would be 2809 minus 100. The answer is going to be 2709. That's the answer that they were looking for. And that's it. We're done. So this is the practice test. You guys should also be doing the bootcamp review packet. I'm probably going to make one more YouTube video where we do a brain dump, where I just go over all of the things that you should write on your formula sheet before you even start the test. And that's all.